Hi everybody, today we're going to talk about heat shock proteins, a little bit different than our normal subject matter, but something I've become increasingly interested in. So what are heat shock proteins? We can think of them as little chaperones or little shuttles that work in our cell that aid in protein folding, that prevent aggregation of misfolded proteins and repair damaged proteins, basically allowing our cells to live healthier for longer. Here's a really nice review by Rhonda Patrick regarding sauna use, and I like it because it discusses heat shock proteins' role in preventing protein aggregation, which we know is a hallmark of various conditions, including neurodegenerative disease, cardiovascular disease, and there are some studies, retrospective, finished studies, that show that extended sauna use, even when controlled for most other factors, promotes longevity and lifespan. And could heat shock proteins be that link? So, how do we improve heat shock proteins? What are evidence based strategies? And if you want to look at those studies, they're all on my website. We've seen that polyphenols, which are antioxidants in plant based foods and teas, can relieve heat stress injury and induce heat shock proteins. We've seen in some studies that calorie restriction can potentially induce heat shock protein expression. And then we've seen high fat diets in short bursts induce heat shock protein, potentially due to the short term stress, but long term high fat diet actually led to decreased expression of heat shock proteins. I would say this research is low to moderate in strength. We know that polyphenols are good for us. We know calorie restriction is good for us. We know that a moderate diet with healthy fats rather than high saturated fats is good for us. Do we know that these are directly related to HSP or heat shock protein expression? Not necessarily, but it is an interesting potential connection and something I think we'll learn more about in the future. One of the best things for heat shock protein induction is exercise. Exercise, like sauna, is a form of hormesis. It's a short-term stress that induces repair functions in our body. There have been studies that show that aerobic exercise and resistant exercise can induce heat shock protein expression. Some studies showing even chronic training can increase your baseline heat shock protein expression. We've touched on this, but heat therapy / sauna can induce heat shock protein. That makes sense because you are in a hot environment. Repeated sessions may also increase your baseline heat shock protein expression, similar to exercise, and we'll see that in a diagram moving forward. Based off the literature, my personal opinion is that sauna or warm water immersion are great adjuncts to exercise. For those that can't exercise, these therapies may be able to induce some hormesis and mimic the benefits of exercise. So here's a graph from Rhonda Patrick's review. As you can see, with heat stress, 163 degrees Fahrenheit, 70 degrees Celsius, there is an increase in heat shock proteins. For those that are non-acclimated, it's actually a little lower than those that are heat acclimated, who are actually starting from a higher baseline, which I think is very interesting. As we alluded to, potential metabolic disease, poor diet, etc., can reduce heat shock protein expression. This has been seen in individuals with type 2 diabetes and insulin resistance. And there are some studies that have alluded to the role of heat shock proteins in maintaining insulin sensitivity and glucose homeostasis, which may be an interesting connection that we might learn about more moving forward. Now, I've learned more about this recently, but heat shock proteins are actually a target for many cancer therapies. Elevated heat shock proteins in the wrong setting can promote cell proliferation in cancer, can inhibit apoptosis, meaning the cancer cells do not die, and of course enhance tumor survival. They've actually found that specific heat shock proteins, when expressed, are associated with poor prognosis and chemoresistance in cancers, such as GI cancer. This is interesting and good to know because there are many therapeutic targets in the pipeline to potentially target heat shock proteins in these cancer cells. There have been dozens of studies already to indicate the response and safety of these medications. There's also clinical trials right now regarding cancer vaccines using heat shock proteins, which I think is incredibly interesting. So finally, heat shock proteins in the right setting in a healthy individual and healthy cells can induce a sense of hormesis, which in a way mimics exercise and can improve one's cellular health, integrity, and lifespan. Heat shock proteins, though, can play a complex role when it comes to cancer cells, promoting tumorigenesis and reducing the efficacy of our treatments. So targeting heat shock proteins may be something we see in the near future as it relates to cancer therapy. A short video, the nuances of heat shock proteins are interesting. If you thought this was interesting, give it a like, share it with those who also might find it interesting. As always, the studies are on my website. Thank you so much for watching.